Thanks, guys. Thanks for being here and spending your afternoon with us. So what we have planned today for you is talking about a very quick overview of what Databricks on AWS is, right? One slide. And then how we operationalized Databricks on AWS at McAfee, what we did to make it happen, both migration and operationalization of it. Then what is McAfee? Why does McAfee care about Databricks? What are McAfee's use cases? And what's McAfee's roadmap for the future of Databricks on AWS at McAfee, right? So that's all we want to talk about. And then call to action, where Hashim will talk about come work for McAfee or AWS. So there you go. Oh, I'm next to you. Okay, so what is Databricks on AWS? I promise it's exactly one slide. Databricks on AWS is the Databricks open platform, the open lakehouse architecture platform optimized for AWS. What that means is basically you can do both data warehousing, analytics, and AI use cases with this platform on AWS. And specifically, it integrates with several AWS services natively. Kinesis we're going to talk about today. It integrates with Redshift. You can basically get data pipelines in and out of Databricks into AWS. It integrates with Glue. You can have a Databricks catalog that you can query with Glue via Athena. It integrates with SageMaker natively through MLflow. So it's really that unified platform with native integrations into AWS built on open lakehouse architecture. Okay, so when we started working with Databricks and AWS, we went with the default network architecture that Databricks provides for AWS, which is basically, it needs an account, an AWS account. It needs to sit in a VPC, right? And you can have a customer managed VPC, or you can have Databricks managed VPC. We went with the Databricks managed VPC, so basically Databricks sets up the VPC for you, and the VPC requires at least 2 subnets that span across 2 availability zones. So that's the minimum requirement, right? And in our case, besides that requirement, we also have, we'll talk about private VPC endpoints to various AWS public zone services later today, but we also have a trusted IAM role that provides trusted access from the Databricks control plane to the data plane. This is the Databricks data plane, basically, how it sits on AWS. Yeah, so nothing extraordinary here. Take a Databricks, and this is, by the way, now is available on the marketplace. So you can subscribe on the marketplace, and you can get it right here in minutes.
Thanks a lot, Kanishk. So I thought to start by talking about McAfee and have a poll or a question. So what's the first thing comes to your mind when you hear the name McAfee? I'm going to pick at you because you told me to go with the poll.
Viruses.
Viruses, OK. What about you, sir? What do you think of McAfee? What security? So that's absolutely the right thing. Whenever I meet someone new and I talk to them about McAfee, the first thing that they say, oh, it's the antivirus company, which is absolutely true. McAfee is a world leader in antivirus. But then I come back to them and tell them, oh, do you know about the McAfee's other products, like VPN and identity protection? And we have this new product called Protection Score that tells you how well you're protected online across all your different interactions. So what happened at McAfee is that we have changed from being device-centric and just protecting the customer on a single device to being more customer-centric and protecting the customer across all their interactions. So we're basically no longer just an antivirus company, and we have a wide variety of products to serve. And by doing so, we kind of created a data problem, where we need to understand how the user is using our products. The other thing is that we understood that the security and protection are very data-oriented. For example, you need to have a data set that tells you about the different viruses out there. Also, you can start looking at the different events the customer is having that can tell you something malicious a customer is experiencing. We also wanted data to understand how to better engage with the customer. How can we provide meaningful engagement? And we want to build those intelligent products that can quickly adapt to whatever is new out there in the world. And of course, we had to drive our business by using that data. So it was very clear for us that we had to be a data-driven organization. And to do that, we had to build a robust and comprehensive data ecosystem to support our use cases. So to build that ecosystem, we thought about the data products that we had to provide. That starts with reporting insights on the top left. And this is just to provide reports that can empower the business decisions. So for example, if we have an A/B test out there, we need to be able to track it. We need to know how well it's doing. Let's say we have a feature out there that's not behaving too well. Let's know about this, and let's alarm internal employees. The second product is ML personalized. And this is more about customizing our features to serve the customer best. An example here can be, let's say a customer just connected to Wi-Fi. Maybe this is a good time for us to tell the user to open their VPN to be more protected. A third product that we have is ML Secure. And this is to use the data and ML to detect new patterns that we have not seen before, and automatically just be able to protect the customer. To be able to create those three products, we had to create a fourth product, which is a Customer 360. And this is basically a comprehensive view of the customer interaction across all our products. This had to be a trusted, easy to use, and complete data set. Now, the trust here is very important, because if you cannot trust your data set, it's very difficult to use it. And sometimes you're better off just doing some random decision. And of course, it had to be easy to use. We had to have a quick action based on the data we have. And of course, it had to be complete, where you need to understand all the different touch points that the user have. To be able to serve all our different use cases, we had to build a very strong data platform. So this data platform had to be secure and performant. It also had to scale really well, because we have a large subset of users. Now, whenever we talk about scale, we have to be very careful, because sometimes you can scale really well, but then your cost does not scale as kindly. So we had to make sure that the platform itself is also cost efficient. Now, to build the platform, we started thinking about the data lifecycle that we imagine. And we put lots of emphasis on velocity, because it's very important that we take actions quickly. If we wait, for example, like days or even hours to tell a user about a threat, maybe this is already a disaster for the user. Or if we're running an experiment and this experiment is not doing well at all, we better just revert it before we have some business impact. So that life cycle starts with ingestion. We know we have over 300 or 400 million endpoints that are sending us data, so the ingestion had to scale really well. That's followed by validation. We had to make sure that we can trust that data, apply some simple validation rules that tells us everything's okay. That's followed by transformation and materialization. Now start building those data sets that tells us about the different products, how well they're acting, as well as start building those ML models that will tell us how to predict the customer behavior or how to provide a better customer experience. This is all followed by serving layer. We had to make sure that our platform can do deployment and data sharing. And of course, eventually we have to get that data outside of our ecosystem to feed it back into the product or into our businesses. So there had to be some kind of consumption layer. Based on this life cycle, we decided to come up with the following architecture. Basically, at McAfee, we designed this cloud-agnostic platform as a service architecture. That's having Databricks at its core. So as the data gets ingested into our ecosystem, we're using Databricks to stream the data into persistent storage. As we're streaming the data, we're also applying some validation. After that, we're doing some batch processing of the data using Databricks again. And finally, we have the data consumption. And this is where we're running all our machine learning models. This is where we're running our reporting and all the other products we spoke of. Now, the beauty of using Databricks is that it allowed us to create our own libraries for ETL. So we did not really have to write much code to instrument a new data feed. Everything we had was configuration driven. And another beauty of using Databricks is that it enabled those native notebooks, so user can just come in and use the data as they want. It also offered like ODBC connections. So now we can use our own BI reporting tools that we wanted to use. Now I'm going to pass it to Kanishk to show how do we run this ecosystem inside of AWS.
Okay, so right. So I'm assuming some knowledge of Kinesis and S3, just fundamental 101, right? So Kinesis is our real-time streaming platform in AWS, and S3 is our object storage service. So as Hashem mentioned, we have telemetry events coming in from millions of endpoints from consumer devices, iPhones, tablets, and so on. And approximately 2 billion events a day is what we've optimized the system for right now. But it can scale further. So we have these events coming in, ingesting essentially into this platform. And the Databricks layer, as you can see over here, right, this which says stream processing over there, right? It's doing an ETL job, essentially consuming all those, reading from Kinesis, right, and putting them into S3. And at 2 billion events a day. Now, when you do that, there are some optimizations you have to do so that you don't miss these events coming in, and you can also basically leverage S3 for object storage. So the first thing is, from a network perspective, right, we want to use a VPC endpoint. So in the case of Kinesis, it's an interface endpoint. In the case of S3, it's a gateway endpoint. They're basically both VPC endpoints, which basically means that they allow services that sit within the VPC. So Databricks sits inside a VPC in the control plane, right, or VPC, and connects out to Amazon public services, public zone services like Kinesis and S3. But when they connect out to these services, they connect over the Amazon private network backbone, right? We don't go over the internet and connect through them. And so interface endpoints do this in one fashion, where they basically set up a DNS, ENI, elastic network interface for you and do DNS translation. Gateway endpoints modify your route tables for that to happen. So the Databricks process speaks to Kinesis and speaks to S3 over, first of all, over these VPC endpoints. Second, if you look at Kinesis itself, right, we're basically coming in like 2 billion events a day, and which is basically 17 million events every 5 minutes or something. I did that calculation one time for them. So Kinesis itself has some limits, has some quotas. Now, quota is the best way to put it. So Kinesis can, every shard for Kinesis can basically do 2 megabits per second, and you can do 5 fetches per second. So that's kind of, so every consumer can do 2 megabits per second, and you can do 5 fetches per second So how do you basically get all that data in without missing without missing the data, and as well as accounting for the processing that needs to go into storage into S3. Fortunately, Databricks has an amazing connector. It's called the Databricks connector for Kinesis, or streaming Kinesis, or right? And essentially what it is that it is a Kinesis consumer, right, which is executing Spark jobs in the background, and these Spark jobs prefetch that data, push it into a cache, and then a Spark executor then takes the data from the cache, and then when the prefetch is done, and takes the data from the cache and then processes it, right? So Databricks provides multiple configuration settings for this connector they provide. And so in our case, specifically, it's about, to accommodate Kinesis quotas, is about fetching less data, fetching less often, so that we can scale to multiple consumers, right? And account for the 2 megabits per second and 5 fetches per second quotas. And the second thing is about making sure that our buffer duration and buffer sizes are big enough so that we can actually buffer that data without missing events coming in, while allowing S3 to do the processing it needs to get those files into S3. And we need large number of small files really in S3. So that's our optimization with the Kinesis connector supplied by Databricks for AWS, which is the core of this, right? The other thing, if you look at from a compute perspective, right, these are Databricks nodes. So this is the EC2 instances running this Databricks compute plane, right? So one of the nice things about Databricks is that it provides you the notion, the ability to do tagging at the cluster level. And these tags propagate down to the EC2 nodes that are running these Spark jobs. And so in our case, and like in every customer's case, if you're migrating data into AWS, you're eligible for discounts. You're eligible for cashback. We call it the Migration Acceleration Program discounts and cashback. But in order to give you that cashback, right, we need to basically understand how much consumption of data is coming into AWS, and how long are you using S3 EC2 for, and how much data is being stored in S3. So we need to tag these things. And so when you set up cluster tagging with the tags that we provide as part of the MAP program, those tags are propagated, and we can actually accurately find out what's going on with your Databricks, with your consumption for EC2 and for S3, and appropriately pass on the discounts back, which is significant cash savings for McAfee, actually. So that's all on this slide. And of course, S3 has intelligent tiering. That's automated setup. So basically, you go from standard tier to other even lower cost tiers. Okay, this is the other optimization, which is actually very helpful for McAfee, and it really helped us save McAfee tons of, or a little bit of cost as well. So Databricks out of the box allows you to monitor Databricks with CloudWatch, right? CloudWatch is our AWS's logging service, and CloudWatch has what we call CloudWatch logs, where you ingest log data and log as multiple log streams, which could be based on what you're ingesting, time frame or the services that you're ingesting. So what we did for McAfee was used another CloudWatch service, which is in the CloudWatch family, called Contributor Insights. And what Contributor Insights does, it allows us to provide real-time insights into what's happening in this data flow that's coming into McAfee's Databricks deployment. Because what it does, it basically, if you think about what we're doing, we're getting data from Kinesis through a VPC endpoint. We're pushing data out into S3 through an S3 gateway endpoint. These are all elastic network interfaces that are basically network endpoints. And with Contributor Insights, you can actually hone in on that IP address of the network, the private IP address of the network endpoint. You can actually find out then exactly bytes transferred, source IP, of where those bytes are coming in from, destination IP, time, and so on. And you can actually then set, in McAfee's case, we wanted to really make sure that for the bytes transferred coming in, we're basically optimizing cost for them. So we found out, as an example here, that, and this is something we would have only known with Contributor Insights, that they had a NAT, they were initially running a NAT gateway. But the NAT gateway, processes data based on data coming in, as well as based on hourly charge running the NAT gateway appliance. So by substituting out the NAT gateway with a powerful NAT instance, which is basically a NAT software running on EC2 instances, hardened instances, we're able to save them that hardware appliance cost and just basically save on data incoming costs. And again, all that we get real-time insights into that data because Contributor Insights is actually sketching out literally a real-time network visualization dashboard for you for this data coming in to Databricks, going out to S3, and being consumed by S3. In the future, when they get ready for talking to the control plane over private link, which is basically another VPC endpoint technology that allows you to connect, since Databricks runs on AWS and the SaaS control plane, and they're running on data plane on AWS, we can go connect to them again over private backbone. In the future, when they do that, then we can even monitor that connection easily with the same CloudWatch Contributor Insights monitoring setup for them. And this automation at the end of the slide will share the link. You can download it, run it for yourself. It'll work for your Databricks deployment or other areas as well.
All right. So one more thing. Basically, before we existed in AWS, the whole infrastructure that we had was actually in a different cloud. And over there, we had all our pipelines running, getting that data from 400 million devices or more. And we had over 2 petabytes of historical data. And now we knew that we took that decision that we want to now be running in AWS. So how can we do that? Especially with that large data size, 2 petabytes. It was very clear to us that we could not stop our pipelines. So everything had to keep running. We decided to use something called Delta cloning. Basically, Delta cloning allows you to copy data from a source to a destination using the Delta Lake checkpoints. Then you can keep copying multiple times to copy the deltas after the data has been updated. So in our original cloud, we had all our infrastructure running, and then we started copying that data iteratively. So some tables took us like maybe minutes to copy, but some others took us days or weeks to copy. But then we were just able to start our copying operation again. And once we had the data matching in the 2 data sets or the 2 clouds, we were just able to start pointing the data to the new destination and run our pipelines. Since we're using Databricks at the core, it was just really easy to get the exact data matching in the 2 different destinations. So we were able to run the cloud for like 2 weeks. We did some validation, and we saw that we had like over 99.9% data matching. Of course, there was some randomness because depending on the function, if you're doing it random, but otherwise, everything looked perfect for us. The great thing about this solution, it was also very cost effective because the only costs we had to pay for were the networking charges, getting out of the other cloud, and the compute cost to run Delta Lake, or sorry, Delta cloning. So for copying the 2 petabytes of data, we only spent about $20,000 on compute plus Databricks. So I'm talking about VM plus Databricks. So that was a very cost-effective solution compared to anything else that we had looked at. Now, of course, there were lots of other wins for us using Databricks. The first one is adoption. Well, right now we have over 700 McAfee employees that are actively using our infrastructure through Databricks. Those employees are running around 80,000 queries monthly. That doesn't even count the number of queries on BI tools. So as a data group, we consider this as a big win for us and a big step for us to be a data-driven organization. The second big win is about scaling. So initially, we were ingesting like few gigs of data daily to 1 terabyte to 5 terabyte today, which again was amazing how quickly and how easily we're able to scale. Right now, the data lake size is about 2 petabytes. And again, we don't have any worries about that data lake increasing in size to 5 or 10 petabytes. Now, with those wins, we still see some challenges. The first is about cataloging. So Databricks did not offer any kind of enforced cataloging. That meant that all our catalogs had to be living outside of our ecosystem. So that kind of made it a little bit difficult in terms of velocity, because with the large number of tables that we have, you find like lots of exchange in emails about which data set we should be using. The second, again, with the high number of users that we had a lot of notebooks, over 10,000, that are custom to different users at McAfee. And that honestly is kind of a maintenance nightmare. The last problem that we have right now is about the visibility of how the data is being used. So absolutely, Databricks offers some audit logs that tells you which tables are being queried. But what we care for more is how those tables are being queried, which columns are selected, how many rows were fetched, and is the data analyst writing the query the best way possible? Are they joining the data properly? And that is not visible for us today. And the impact of this is just impact on performance and velocity for us to be able to produce reports quickly. Now, all in all, our integration with Databricks has been really successful, and we were able to mature a lot as a data organization. So the first step we had, of course, was getting the platform up and running, which again wasn't very complicated. And then we're able to receive the data, we're able to validate it quickly, and we're able to analyze the data and provide those reports right away. As soon as we had that, we as an organization at McAfee, we became data aware. We had those success criteria or success metrics being tracked and being reflected upon. Then we started building our Customs 360 in Databricks. And this is about stitching the different endpoints to create this beautiful mosaic that tells you how the customer journey was like. And then we're using now that data to feed back into the product. So we're doing more product personalization. We're doing feature recommendation for the user. And probably as you heard in today's keynote, the future of data is ML. So this is also how we see it here at McAfee. So right now we're trying to use that data to predict how the customer behavior will be like. Look for data patterns that we did not see before, and we're actively doing that. And of course, we're looking to develop new features that can protect the customer better. At the end of the day, our main goal here at McAfee is to keep the customer protected and make sure that we can easily adapt to whatever new threats are out there in the field. And it's very important for us to be able to do that at scale. And this is where Databricks is helping us being very successful. And as we do so, our customers can confidently enjoy a safer life online. All right. So I think you guys have been a great audience. Thank you very much for folks who contributed. I would like to invite you also to take a look at our jobs at McAfee. We have a bunch of jobs in our data org. We're growing a lot. And again, that's due to the success of our data platform. And we have some more readings if you guys would like to learn more. And yeah, we'll leave it back.
Jobs at AWS, tons more.
No, come from McAfee. Right, thank you.
Thank you. Oh, yeah.
Okay, cool. So I think we have 5 minutes or maybe a little bit more for Q&A. So if you have some questions, yes.
There you go.
And then I also have some comments to share.
Yeah, a question about the latency from the endpoint or devices till it hits S3. What kind of latency are you getting?
Right. So the question was, if I get it correctly, the question was from the endpoints on the devices to S3 end-to-end, what is the end-to-end latency? Did we measure that? Like, I think we have measured certain points.
Yeah. So from the endpoint to the, let's say, the receiving endpoint like Kinesis. So this one, depending on the criticality of the event itself. Some events are sent immediately because they're really important. Some others are batched and sent later on. So depending on how important these ones are, I think based on that, we usually look at, it's within milliseconds, I believe, that transmission.
Yeah, the number I have, like I know it's 17. We're handling 17 million events every 5 minutes. That's what we're doing. Right? Yeah. So 2 billion a day. So then you can count like how many.
I would be calling it in milliseconds. Yeah. But then we can always like try to elongate that latency if we don't really care about using data right away.
That's also true. Buffer a lot.
Yeah, I have a question on delta cloning.
Yes.
You mentioned that you transfer 2 petabytes of data, right? Yes. Is delta cloning is a Databricks product, or it doesn't work only between?
Databricks product. Yes, correct. Yeah.
It works only between 2 Databricks on other cloud to Databricks on AWS, or any source systems?
So as long as the data is stored in the Delta Lake format, we can copy it from one source to one destination. But I believe you have to be running it inside Databricks.
Right. So I can answer. So by the way, that's one of the, this is one technology you want to take away from all of this is Databricks Delta cloning. It's really powerful. So basically it runs these parallel Spark jobs on Databricks compute, right? And then copies into. And we were able to do both streaming transaction copy as well as copy into transactions, both of those, and with incremental copying. So like you can start from where you left off again. That's amazing. And so that's really cost effective, and they were able to continue the streaming transactions along with the copy into job as well. So it's, I don't know the pricing structure of Databricks on that, but it's from the compute instances, as you mentioned, is what the whole thing was $20K for 2 petabytes of data end to end.
Yeah, and took us, I think, about 3 weeks to copy like the 2 petabytes of data. Now, you can definitely copy it faster if you want to, but again, like it depends on your cost structure and how much you're willing to spend.
So you mentioned that there was a scale with cost efficiency. Like, how did you achieve that?
Sorry, do you mind repeating the question?
Scale with cost efficiency, like as we saved more cost as we scale higher?
Yeah, so how did you achieve it, like on AWS using Kinesis or Databricks or like what?
Right.
Or using some monitoring?
So there's multiple, exactly. So how do we do cost optimization across this, right? So because this is if you look at it from just data perspective, it's a lot going on here. So there are a couple of things. One is from a network perspective, right? In terms of just cost by using VPC endpoints across the board, without going over the internet, saving on latency over there as well. Second is, by contributor insights monitoring is one of the, I think, it's a little more detailed topic in CloudWatch, but basically what it is that gives you granular visibility into what is going on in your network transfer or what is going on in your pipeline itself. So you can act, and it automatically sets off alarms for you in terms of threshold that you set. So that's how we were able to replace the NAT gateway with the NAT instance and save them another few $1,000s or more every month, just like that, right? The third thing is compute optimization. So when you do this kind of data work with AWS, we give money back to you, like in terms of, you're spending so much, your incremental growth in EC2 is so high, so we'll give money back to you. But we need to tag that. We need to understand what is your actual growth. And because if you think about how this works, they spin up clusters and they spin down these clusters based on the work going on, right? So we need to tag these ephemeral EC2 instances, nodes coming in, and also the data that's being stored in S3. So that's cluster tool tagging that's out of the box with Databricks, and that we can just leverage for giving you making you part of the program, the map program. And the final thing is I would just, again, re-emphasize Delta cloning. It's so simple to set up, so simple to use. Tomi right here, he actually wrote the Jupyter notebook for us as well, right? So, and if you look at the notebook, it's really SQL on both sides, and it's very, very cost effective. We looked at ISVs, vendors, softwares, and we just went to many vendors to look at COTS options to do this, and here's a Databricks native option, which is just so simple to set up in Jupyter notebooks.
I'll just add one more thing about like cost saving. So definitely there are a couple of parts that we had to do really well. One is tagging, making sure all our jobs are tagged, so we can go back to the cost explorer and see where are we spending more. Okay. And the other thing we try to do a lot is that we come back and revisit our jobs and look at the monitoring, seeing how well is our cluster size scaling for the job type. Sometimes you see like, oh, hey, I'm not using any of the CPU. Maybe I should switch to a cheaper VM. Or sometimes you figure out, okay, no, I need more compute power, so I'm going to add a bit more nodes to this job, and so on. And yeah, always iterating and like always coming back and saying, what have you done is very important. That's something we try to do as frequently as much as possible.
Any other questions?
As part of cost did you use spot instances as part of cost optimization?
We didn't so the question is, did you use EC2 spot instances? No, we didn't. We didn't have to. We didn't do spot instances because we wanted persistence on the instances to be there. I think the biggest thing with EC2 instances and compute jobs is that you need to basically tag them so that you know what's running and you can resize them if you wanted to.
And for Delta cloning, I would say we tried using spot instances, but they don't perform really well for long-running jobs, so I would not recommend it. But honestly, there are some other jobs that, if the job is not long-running or quick, you can probably use spot instances in that case. And that's something also we do in certain jobs.
Just shameless plug-in. Tomorrow there will be a session on Graviton about cost savings, if you want to come. Guess who's presenting?
We use Graviton instances as well. Apparently, Databricks clusters run on Graviton too. So, but we didn't have to go there. Yeah.
Questions? No. Okay.
Right.
If we go back, please, to slide 15.
Sure.
I have some comments on that. We still have 3 minutes. I'm going to go back.
Here. This one?
15.
Okay. That was an easy slide.
I think 15, you said?
No, that is 13. The one that talks about the challenges, actually.
This one.
15. Yes.
This one. As a Brickster, as a solutions architect at Databricks, I cannot prevent myself on commenting on this. So,
okay.
About the challenges, so you just mentioned that with Databricks, or at least maybe by the time that you have conceived this solution, there was no cataloging solution, but I think Unity Catalog could maybe answer some of the questions about enforced cataloging, and actually Unity Catalog can you can even integrate external catalog. So if you're using today Glue, for example, you can also have it within the Unity Catalog. I think it will make your lives easier in managing all those, let's say, databases, schema, and different tables. And actually, there will be talks and in the keynotes about Unity Catalog. Visibility on how data is used, actually also with Unity Catalog. It's not yet here, but I think it will be in preview in the next months. So it's not really something that exists today, but you can see maybe also today or tomorrow there are some keynotes about it, that you will be able to track exactly what is happening in your table. So what are the most used query on your table? Who are the most frequent users that are using this table? The lineage also, so we will have some sort of listeners on the Spark application to track from where you're getting the data, from where the Spark application is actually consuming the data, and where is actually writing the data, whether it is back to Kinesis or to S3 or to wherever sync. And so I really recommend you to go maybe and check what will be announced in the roadmap for Unity Catalog. I think those two challenges you would be able to answer them with the upcoming, let's say, announcement that we have in Unity Catalog. And then for the 10,000 plus notebooks, it's really challenging to handle 10,000 plus notebooks, especially if they are being created and managed on daily basis by different teams and engineers. But we have repos, and repos can make your notebooks and whatever you are doing on Databricks in the workspace and the development environment link to your Git repo, whatever Git provider you are using. And so it could make you also continue on the best practices that you have, for example, for CI/CD and maintaining your production workload. So you can have, for example, on repos, different projects or maybe folders that are managed by teams or managed by different roles and different developers, and you can have them integrated with your GitHub repo so you know exactly what is happening, and then once you push on your Git repo, it will trigger a small CI/CD cycle to do your unit tests and so on. And so you can do a lot of things in there. So that was just some small comments. I hope you accept that from my side.
Something we love really.
Use Unity catalogs.
Yeah, we are starting to do a POC with Unity catalog, and something we really love about using Databricks today is that you guys are always improving, like always producing something new and always improving whatever you have, right? And that's something we really love about working with Databricks.
Yeah.
And I think what brings us success.
Definitely, and I think you would also love the upcoming, let's say, announcement that we will have today and tomorrow that will help you answer your challenges at McAfee.
Thank you very much.
Cool, thank you very much, guys.
Yes.
Thank you. If you have further questions, please reach out to the booths, Databricks and AWS downstairs. Thank you.
Awesome.